It's 2:39.
Do we have class tomorrow?
So Sydney, if you're watching this, we are just starting. It's 2:39. Oh, 2:40. And Isabel just asked if we're gonna have time for homework. We do have class tomorrow. It's second period. First period. Oh my gosh.
Second period is B.
That's right. B and F, because I always get those mixed up on Mondays. This will be easy.
No, we have psych. We have.
B is first on Monday, and then it's F, and then on Wednesday it's switched. It's F period first, and then B period.
Because I have a psych test, but I have to come in early to take it. I thought I was going straight there, so I have to take like 3 pages or something. Then go get it.
Oh, so why would you come early and not just take it at lunch?
There's no lunch.
Okay, we'll figure it out. Okay, particle motion. This is all review. Velocity greater than 0, moving to the right. Less than 0, moving left. Displacement, right? Displacement is the integral of velocity, right? Because what happens when we integrate velocity, we get the position function, right? Evaluated from A to B. So we're going to have x of B minus x of A, right? Also, like our end position minus our initial position. And then if we have a position, right, we could take the initial plus the displacement. So if I'm trying to find like a position at B, we could take our position at A plus the displacement. Right?
Oh, that's
Does that look familiar?
Yeah. That's right. It's just
It's really just a variation of this displacement, which is the fundamental theorem of calculus. That's really do you see what we've done? It's like just kind of moving things around. Usually we would write it like, if I want to find a position at B, that would be f of A plus the integral from A to B of f prime of x dx. Does that, right? We use that a lot in AB. And then total distance traveled, it's just going to be the integral of the absolute value. Sound familiar? All right. Okay, so here's our velocity. When is the particle moving to the right, to the left, and stopped?
So is that just on the so you find when the velocity is 0 and then put on the number
Yep.
line?
So we're going to do 2 cosine t. Of course, the 2 doesn't mean anything. And we want to look specifically on the domain from 0 to 3 pi over 2. So that's going to be...
So 0 and pi?
Pi over 2...
Oh, yeah.
Cosine 0.
Oh.
Okay, so we'll make a quick little number line here. I'll call this velocity. So we have 0, pi over 2, 3 pi over 2. Okay, so we picked something between 0 and pi over 2. Cosine is...
So like 1.
Well, even just think like on the unit circle. 0 to pi over 2, cosine's going to be positive. And then pi over 2, so here, cosine's negative. Okay, so we're going to say it's moving right. We could either use interval notation. Are we okay just using intervals?
Yeah.
Okay, so technically it's starting off at 0. So I'm going to use bracket 0 to pi over 2, and then parentheses. It's moving left from pi over 2 to 3 pi over 2, all in parentheses, right? Because then it stopped. at t equals pi over 2 and 3 pi over 2. So literally no calculus involved. It was just interpreting the velocity.
Wait, but wouldn't it also be stopped at 0 then? Or like, why do we include
No,
So- Yeah, so it starts out moving in a positive direction because if we were to plug in 0, cosine of 0 is 1.
Oh.
So sometimes we include the endpoints. If it's not stopped at the endpoints, we include it. But we didn't include 3 pi over 2 because that was a value where it was stopped. Find the particle's displacement for the given time interval. Okay. So that's going to be the integral from 0 to 3 pi over 2 to cosine t dt.
So 2 sine t from 0 to 2. And then 2 times.
So it's going to be negative 2. Right? Because 3 pi over 2 sine is negative 1. So 2 times negative 1, sine of 0 is 0.
And the final position would be.
And then the final position, so if s of 0, s of 0 equals 3, what's the final position?
1.
Position equals 1. And then total distance traveled.
Wait, how do you get final position?
We take the initial position, which is 3, and we add the displacement. And then for C,
Is that just the absolute value? Yeah.
would you be heartbroken if we didn't do this by hand? And I just told you the answer.
Yeah, it's so hard.
Right? Because what would we actually have to do? We would have to split this up into 2 different integrals. We'd have to do- and then we'd have to make this the opposite. Save time.
Yeah, we have to do like 0 to pi over 2 and then pi over 2 and 3.
Yeah. Save you some time there. I'll just tell you it's 6 meters. I think we can do that in this lesson. Right?
Yeah.
You've earned it. Oh, did you get all that?
All the homework, can we also do that?
Yeah. I'll let you use your calculators. In fact, I think this test...
Wait, I'm confused why I have to split up into 2.
Oh, because velocity is positive here, but negative here. So if we were to do this by hand, we would have to break this up into 0 to pi over 2 of 2 cosine t dt. But then I would want to, this will be, yeah, because that's going to be negative. So I'll subtract it. Because we want this to be positive, right? Okay, car moving with initial velocity of 5 miles per hour. I'm just going to write v of 0 equals 5. Accelerates at 2.2 miles per hour per second.
So that
So
is.
do we just find velocity, so the integral of acceleration, and then
Yeah, so we're going to integrate. So we want to find, do you want to find the velocity function and then just plug it in or?
Yeah.
Okay, that's fine. So I can do v of t is going to be the integral of acceleration. So that's going to be 2.2 t squared over 2. So 1.1 t squared plus c. So that's going to make c equal to 5. So velocity, and this is going to be miles per hour, because when we are integrating it over seconds and it's miles per hour per second, that means our result will be miles per hour. And then we want to do v of 8. Yeah, so 75.4. Okay, how far did the car travel during those 8 seconds?
So is this just the integral of v of t from 0 to 8?
Yes. Now, normally we would put this in absolute value for total distance traveled, but it's all positive, so we don't need to. Now, I will tell you. Do you want to do it by hand?
No.
Okay. Sorry. We have an issue with this answer. This was measured in miles per hour. The limits of integration are seconds. So this answer we have to by how many seconds are in an hour?
36.
Close. Right? Okay, so here's the thing. When we did this last part, right, when we went from acceleration, it was miles per hour per second for 8 seconds. So when we integrated it in terms of seconds, it gets rid of the previous time. So we're just left with miles per hour. But now, if we change this to miles per, or keep this miles per hour, but we integrate it with in terms of seconds, we have to take this answer and divide it by 3,600 to get how many miles, which is 0.0632 miles.
What unit is 227.773?
You tell me, what kind of unit would that be?
Mile.
But it's not a mile though.
How far?
Miles
Correct.
per hour per second?
But it's a weird kind of situation because this is miles per hour, and when we integrate it with regards to seconds, this answer is now what?
Miles per second.
Well, I hope it's not miles per second because that's a lot of miles per second. I hope a car's not going that fast. Right. So, but it wouldn't be per. I understand what you're saying. It would be like over over seconds. You know what I mean? Do you remember we did these last year?
Yeah.
But I don't think you really
I
encountered.
227.3 is miles times seconds.
Miles times seconds.
So you have to divide by seconds.
So you have to divide by seconds. It's weird. It rarely shows up, but just in case. Okay. Now we have a velocity graph. Particles at x equals 2 when t equals 0, so that means x of 0 is -2. Where is the particle at the end of the trip?
So we just do -2 and then add the area?
Yes, and so let's see. I have this trapezoidal area here, h over 2, so 2 over 2. Base 1 is 5. So I get 6 for the top portion here, right here. And then this bottom portion is a triangle. What do we get for that? 3 times 4, so that'll be 6 also. So good. So, did I forget my? So yeah, it's basically -2 plus 6 minus 6, so we get -2. All right. Find the total distance traveled. So here, we don't care about the initial.
So it's just 6 plus 6.
6 plus 6, so we got 12. Good. 6 plus 6, 12 meters. Go. Good. Oh, Isabel, maybe there will be time for homework. Because we're done after this page. Okay, total consumption over time. Just remember, if you want to look at the cumulative effect, we're just going to integrate whatever the rate is, dt. Like an accumulation of something. So you probably remember, like, I don't know, problems with I'm trying to think, like, okay, did you do the problem with the bananas at the grocery store? Like that, the response question from a few years ago? No. Like the rate at which the bananas are put onto the display is this, and then the rate at which they're taken away. Usually you talk about varying rates. They're somewhere on a free response question. Well, the rate at which something, or people getting in line at an amusement park, that's usually one, or cars entering a toll plaza or whatever.
Is the cumulative effect?
It's like going to be like the total amount of cars or the total.
Okay, so it's like an amount. Not like
Yeah. It's like it's going to be it's going to equal an amount at the end. So this is going to be some amount. So if we have, here's our example, a rate of consumption of oil in a certain country, okay, is modeled by this function. So this is a rate. T is the number of years after January 1, 1980. What's the total consumption from January 1st, 1980 to January 1st, 1990?
So we can just say the integral from 0 to 10 of that.
That's it. And we can plug this in. What do I have here? So I get 137.205, and these are billions of barrels. That's all you have to do. Okay, last one. So we have a pump connected to a generator. So it's operating at varying rates. So notice have these values for the rates. The rate is gallons per minute, and it's recorded at different time intervals. So we want to use trapezoidal to approximate how many gallons were pumped during that hour. Okay, so the first interval is from 0 to 12, so 12 over 2, 60 plus 64. Now, if these were nice and evenly spaced, we could just take out the h over 2, but the next one is 12 to 20, so that's going to be 8 over 2, 64 plus 58. Don't worry, I'll just have you set it up and then I'll tell you the answer. Next one is what? 8 over 2. Good. And then 6 over 2. I'm going to just write it down here. 54 plus 62. 16 over 2. 62 plus 60. And the last one's 10 over 2. 60 plus 62. 3,584 gallons. And then we could do a follow-up and we could be like, oh, what's the average rate over that time period? And then you would just divide that by 60. Excellent.